We want to find the exact components of the vector using the angles shown here below. We're assuming the initial point of this vector is at the origin on the coordinate plane. So let's go ahead and sketch the axes. This would be the x-axis, and this would be the y-axis. So notice how the vector is in the fourth quadrant, and therefore this angle here that's measuring 45 degrees wouldn't be the angle of rotation, it would be the reference angle. The angle of rotation is not shown, but we could use, for example, negative 45 degrees for theta, or if we want to use a positive angle, we could use 315 degrees. Of course, we could use any other coterminal angle as well. So if we have a vector v with a known magnitude that makes an angle theta with the positive x-axis, then vector v has an x-component of the magnitude times cosine theta and a y-component of the magnitude times sine theta. Let's go ahead and write this as, in our case, vector p would be equal to the magnitude of vector p times the vector with an x-component of cosine theta and a y-component of sine theta. Again, we can't use 45 degrees for theta because notice how the angle would terminate in the fourth quadrant. The two most obvious angles for theta would be negative 45 degrees or 315 degrees. Let's go ahead and use 315 degrees. So we would have vector p is equal to the magnitude of 28, and then times the vector with an x-component of cosine 315 degrees, and a y-component of sine 315 degrees. Now to find these trig function values, we can either use reference triangles of the unit circle. Let's begin by using a reference triangle. Notice how if we were to sketch a reference triangle, here we would have a 45, 45, 90 reference triangle. Let's go ahead and use this triangle here. We know we can label the legs 1 and the hypotenuse square root 2. Again, this would be our reference angle. We'll call it theta prime. But because we're in the fourth quadrant where the y-coordinate is negative, we would change the sign of this 1 to negative 1. So using our reference triangle, notice the cosine of 315 degrees, using our reference triangle, would be the ratio of the adjacent side of the hypotenuse, or 1 over square root 2, and the sine of 315 degrees would be the ratio of the opposite side of the hypotenuse, which would be negative 1 divided by square root 2. So this gives us 28 times the vector with an x-component of 1 divided by square root 2, and a y-component of negative 1 divided by square root 2. Let's go ahead and perform this scalar multiplication. So we'd have 28, or 28 over 1, times 1 over square root 2, comma, 28 over 1 times negative 1 over square root 2. So the x-component would be 28 divided by square root 2, and the y-component would be negative 28 divided by square root 2. So this would be vector p in component form. We could rationalize these denominators and then simplify, but I also want to show how it would look if we found these trig function values using the unit circle. So again, let's start with vector p equals, we know it's going to be 28, and then for cosine 315 degrees and sine 315 degrees, if we use a unit circle given here, notice how the trig function values are rationalized. So cosine 315 degrees is equal to square root 2 over 2, and sine 315 degrees is equal to negative square root 2 divided by 2. So it's the same values we found up here, it's just they're rationalized on the unit circle. So the result will look different. We would have square root 2 over 2 here, and negative square root 2 over 2 here. And now when we multiply or perform the scalar multiplication, we'd have 28 over 1 times square root 2 over 2, and then we'd have 28 over 1 times negative square root 2 over 2. And notice here we can simplify before multiplying. There's 1, 2, and 2, and 14 2s and 28. and the same thing here. So the x component would be 14 square root 2, and the y component would be negative 14 square root 2. So I think it is important to recognize that these two vectors are equivalent. And again, if we rationalize these denominators, they would simplify to this result as well. I hope you found this helpful.